Hey, for this one, quadrilateral GHJK is a rhombus. What is GH? What is HK? So first off, I can see it's a rhombus. I know that all four sides are the same. It asks me to find GH. GH isn't marked with anything over here with an algebraic expression, but HJ is 3x plus 1, which means GH is also 3x plus 1, right? So if I figure out how long that is, I can figure out how long that is. We all buy that? Right? And in order to find out how long that is, I have to figure out what x equals. What would tell me how to find x? What fact here?
2x plus 3 equals 4x minus 7.
All right, so 2x plus 3 equals 4x minus 7. Why is that true?
Because they're diagonals.
They're diagonals, and what do?
Bisect.
They bisect each other, right? So these diagonals do bisect each other. Again, the bisect part's going to help us here because we're dealing with the segment lengths. I use different colors so there's no confusion. This little piece is 4x minus 7. That little piece is 2x plus 3. Those two pieces should be equal to each other. So all right, 4x minus 7 equals 2x plus 3. Again, I take a fact with a property to create an equation. And then I solve the equation. I can figure out what x equals. I've got two x's. I've got two numbers. I'm going to put the x's on one side. I'll take the 2x to the left. It becomes negative. Move the 7. Negative 7 to the other side becomes positive 7. 4x minus 2x makes 2x. 3 plus 7 makes 10. So divide both sides by 2, and x equals 5. If I do a quick check, like I like to do on these problems, quick check means that if I stick x back in, it should make the fact that's supposed to happen, right? These are supposed to be the same length. So, what's 2 times 5? And 10 plus 3? 13. So this side is 13, this piece. From G to, let's call this L. From G to L is 13. And what's 4 times 5? And 20 minus 7 is? 13. So we can see that with x equals 5, we get equal measures. JL and GL are the same length, right? Next, once I know x equals 5, and I know 5 is the right answer because the fact that was supposed to happen happened, I can go over here to figure out what HG is. 3x plus 1. So 3 times 5 is 15. 15 plus 1 is 16, right? So GH equals 3 times x plus 1. We're changing x to 5. GH equals 16. So that wasn't too bad, right? So next they ask us to find HK. That's interesting. Does anybody have any thoughts off the top of their head how we're going to find out how big HK is?
Add 13 and 13.
Add what?
The two things you just found for...
So 16 and 13 makes 29?
Not that, the GJ or whatever. Instead of the same as HK.
So you add 13 plus.
Well, GJ and HK don't have to be the same.
I don't know.
They're not required to be the same.
Well, then I couldn't tell you.
What? Very good. What Emma noticed, it's not drawn in the picture, but again, we have a rhombus, right? If you fill in stuff you know about a rhombus, the two diagonals bisect each other perpendicularly. So this is a right angle, this is a right angle, this is a right angle, this is a right angle. If I focus in, let's say, on this right triangle, GHL, that's a right triangle. I don't know how big that piece is, right? HL, oops. I don't know how long HL is, but I'm calling it Y. I know GL is 13. These are my two legs. And 16 is across from the right angle. That makes it a hypotenuse, right? So I know that Y squared plus 13 squared is equal to 16 squared. So I just apply the Pythagorean theorem. Anytime you see a right angle in a picture that creates a right triangle, keep the Pythagorean theorem in the back of your mind. You might have to use it. It's always leg squared, the two sides making the right angle on the one side, equaling the hypotenuse, the side opposite the right angle on the other side. Okay? Once you've established the Pythagorean theorem, you create the equation. Now you've got to solve the equation. The numbers are either on the same side or different sides. If they're on different sides, you're going to have to move this over here. But before I do that, I want to square everything. So y squared I don't know yet. 13 squared is 169. 16 squared is 256. So square everything. And again, I want the numbers together. If they are, just add them up. If they aren't, you got to move. So 169 moves across. It becomes negative 169. So y squared equals 87. And if y squared equals 87, y is going to equal the square root of 87. we grab our calculator, because I don't know what the square root of 87 is off the top of my head. It's bigger than 9, right? Square root of 81 is 9, square root of 100 is 10, so between 9 and 10. But to get a more accurate answer, square root of 87 equals 9.33. Go a couple decimal places. Right? Notice that y does not answer the question. 9.33 is the distance from H to L. That's what y is representing, right? So 9.33 is that piece. But can everybody agree that LK would be the same exact measure? All right, so LK is also 9.33. So if I want to find out what HK is, from over here, HK would equal 2 times 9.33. So HK would equal 18.66. So we're still drawing on information from previous in the year, right? Pythagorean theorem. All right, so everything you've learned up till now is still alive and well, might need to be used. Just because we're in the rhombus section of the book doesn't mean everything's going to be about a rhombus. All right? You might have to draw on previous knowledge in order to answer the question they're asking for. You might have to find something they didn't ask you for to find something you do ask for. They didn't ask me to find GL, but I needed that 13 to find that, right? So sometimes you have to find things they don't ask you for to find what they're asking for. So keep an open mind, draw back on previous knowledge as you're doing the problems, think through the process, and get as much done as you can on your own as possible before you come asking for help. The more you do on your own, the more the help will make sense when it's given to you.